the deal. We're going to get a function. I'll call it f of t. In this case, I'll make up a function. I'll say f of t equals 3. And we want to take the Laplace transform of that function. Now, there are a couple different notations for this. It's denoted in a couple different ways. One way to do it is as it's written in this first line above here with a capital F. And the variable, the independent variable on that Laplace transform is going to be an S. Another way to denote the Laplace transform is with a fancy script L and a couple of squiggly lines, a couple of brackets. Either of these lines mean the Laplace transform of the function f of t. Now let's just go ahead. Obviously we don't really have a whole lot of insight into what this Laplace transform actually is or what it does yet. But let's just go ahead and try to find the Laplace transform of that function using the definition. So all we have to do is we have to plug this function into the definition. And we'll get f of s is the integral from 0 to infinity e to the negative st times 3 dt. Okay, so that's our Laplace transform. We just have to take the integral. Now, notice that our integral, or our variable, notice that our variable of integration is t. S in this case is a constant. And I am actually going to put another restriction on s in just a minute, but for now, just assume s is a constant, like 5 or something like that. So if we want to actually do this integration, of course you pull the 3 out because it's a constant. And all we have to do is do that integral. Now it is an improper integral. You'll remember improper integrals from possibly your Calc 2 class, maybe your Calc 1 class. So we're going to have to mess around with that. But let's just do the integration first. The integral of e to the negative st. Keep in mind, s is a constant, so like 5. So what happens is we actually pull out a negative 1 over s when we integrate. And we get e to the negative st, and the limits on that go from 0 to infinity. Now, if you want to do that with a few more steps, what you would do is you'd say u is negative st, du is negative s dt. Again, the variable of integration is t. You'd make your substitutions back into the problem, and you get integral of e to the u du, but you have this extra negative s, so you'd have to pull out a negative 1 over s. That leads you down here to that integral. Okay, so now we just have to plug in our limits, infinity and 0. Now what you learned in a previous class, when you're plugging in your limits for an improper integral, you write 3, I'm just going to copy this down. Oops. We're going to want to limit as, let's say, b goes to infinity. I'm going to copy this down, 3, 1 over s, e to the negative st. And now we're taking the limits from 0 to b. Then we take the limit as b goes to infinity, and this is how we do improper integrals. It's a technicality, but we should write it down. Okay, so now I'm going to plug in my limits, b and 0. So limit as b goes to infinity. If I plug in b, I'm getting 3 times 1 over negative 1 over s, e to the negative sb. Again, I'm plugging that in for t because t was our variable of integration. And we have a minus 3, negative 1 over s, e to the 0. Of course, e to the 0 is 1. Okay, so this term over here, we're pretty good with. It's just going to turn out to be 3 over s, negative times a negative. The term with the limit in it is also not too bad. You'll probably remember that the limit of an exponential function as the power goes to, say, negative infinity is just going to be 0. One way to think about that is e to the negative x. The function looks like that. And as x gets bigger and bigger and bigger, that function goes to 0. So, I argue that this whole limit is 0. And we have a plus 3 over s on that term right there. E to the 0 is 1, of course. So, our Laplace transform of 3 is 3 over s. Now we just blindly plugged 3 into our definition of our Laplace transform to find that.